Hello, good afternoon, everyone. Yep, I'm Sam, and I'm going to be talking today about improving application predictability with this library called XState. Um, cool. So obviously, we don't have the benefit of doing this in person, so I thought I'd just put a picture up of myself. So I'm Sam. I'm a Leeds-based JavaScript developer. My hobbies include running, and I also like predictable user journeys. Things I don't like are viruses named after beers. I wrote this presentation a while ago, and that was still funny then, but I don't think anyone's really enjoying the joke still now. And things I don't like are unpredictable user journeys. So I'm going to show you a screenshot now, and I think a lot of people may have seen something similar to like this in their jobs. So this is from a fake client called Alex for a completely fake website called LaceUp. Now, anyone that's seen any talks I've done before, I normally use this example. They say to scratch your own itch, so that's exactly what I'm doing. So this is just an email from this fake client called Alex, and he's basically asking, hi, we've got this new page that we want to create for our site. It's going to be a page, and we want to put loads of race tiles on there, and we want the user to be able to click onto these tiles to get some information about the races that are on at the moment in the UK. So that sounds all right. I mean, what you might do as a developer now is you might take your team into a room with a whiteboard and draw on there how you might think about solutionizing this project. And your drawing might look something like this. So that seems on the face of it to be pretty simple, right? We want a loading screen, a screen with a lot of race tiles. If I click on it, then modal should appear. And if something goes wrong, I should see an error. So if you think about the actions that are being dispatched to the states, there's not that many. So we want to load some races, show an error, click a tile. It's fairly easy to see the order that they might be dispatched in. So our application is fairly predictable. We don't really need to put anything in place to think about how that might fall into place in the way that we want to. Email number 2, increased requirements. So the client now doesn't just want a page which shows tiles of races. They also want a wizard which asks the user a bunch of questions to ascertain what level of runner they are. So they want to know how many races you've done, how fast you did those races, your level of experience. If you have done races, they want to know how fast you did them in. So it's a lot more complicated than the original requirements. Now, okay, you take that, you go back into your room with a whiteboard and you think, how the heck are we going to put this together then? And you might end up with something like this. So you can see that instantly it's a lot more complicated. And we kind of, if you look at the diagram on the top left, the actions that are being dispatched to the state suddenly become a lot more complex. And how do we know as a developer that calculating ability shouldn't come after loaded races, shouldn't come after race info submitted? It gets really complicated. It's not predictable. So what I'm going to be talking about today is kind of a technology that can be used in order to take something which looks quite jumbled into something that looks like this. So don't panic. That's the first thing I want to say. It looks ordered, but it looks like organized chaos. I do realize that. But what we're going to be doing is breaking this down into something that's a little bit more digestible. So we want to talk about state machines. And what is a state machine? Well, the idea of a state machine has been around for years. Anyone that's studied computer science at uni, I didn't personally, I did chemistry, but I've been told that it's a concept which is drilled in quite low level. The theory of a state machine as a concept is essentially saying that there are a finite number of states in a system, and the system can only exist in one of those states at one point in time. And transitions between states can only happen between allowed levels. So you can't transition between state 1 to state 3. You can only transition from 1 to state 2. And so what this does is enforces a rigidity in your application to allow you to guide the user through. And as a developer, allows you to map your happy and unhappy paths. So I just wanted to show you kind of the anatomy of a state machine. So you can see that it's made up of these things called nodes, which is kind of the finite status of a system at any one point in time. So you think about an application being in a loading state, that would be you'd be in the loading node at that point in time. And then also transitions. So this is how you move from one state to the next. There's also this concept of extended state, and now this is kind of contextual information about your system. So this could be something like objects or strings or numbers to relate as to what's going on in your application at any point in time. So there's quite a few libraries out there which can be used in order to kind of build this idea of a state machine into your app. But one which is really gaining some traction at the moment is XState, which is created by a guy called David Khourshid, who's a software engineer at Microsoft. You just type his name into Google. He's done loads of talks, as Luke said, at conferences kind of all around the world. He's been very busy, trying to spread this idea. He's remarkably active on the actual Git repo as well. So if anyone's interested in this, like it's a really good one to get involved with. So why do I like it? Well, it's really well supported for a start. As I've mentioned, there's loads of contributors. It's on iteration number, oh crikey, I can't remember. I think it's 5, coming up to 5 now. So it's had quite a few major releases. It's written in TypeScript, which is really great because it means that when you're trying to plug your application in into something to improve its predictability, it really helps to know what shape that data is going to be coming back in. And also the tooling is excellent. So as you'll see in this presentation, there's an online visualizer and also a Chrome extension, which you can use to see what your system is doing. And the last thing is that it's framework agnostic. So you build all your business logic into this machine, and then you can plug it into any front end that you want, any front end framework using an array of different tooling. So taking that really complicated diagram, we're just going to focus on the top left for now. So what is like a really simple state machine? What would that look like in XState? And what you can see is like it's very similar to that diagram I showed you before. The notation that you get is like object notation when you're configuring your machine. So I've called this machine function. I've given it a name. And you can see that I've got 3 state nodes, info1, info2, and info3. And each of these has an on property, and that is how this is the only transition that I can dispatch in order to move between them. So from info1, I can only ever move to info2. From info2, I can only ever move to info3. So I'm restricting kind of the paths that the application can take so that we don't end up in a kind of a horrible mess and a state that we weren't anticipating being in. So if I just click this button, you can kind of get a feel for the tooling that this application uses. So this XState visualizer, I've just got my machine config on the right, and you can see that it's completely interactive. So I can see the events that are being submitted in each case. And so I've actually moved completely through the application to the final node of next here. So yeah, this is some really great tooling to kind of try and visualize your apps. Okay, so how does that look when I try and plug it into a framework like React? Well, what you can see here is a really basic implementation of XState. So you can see I've imported this hook at the top of the use machine. And when I call this on my machine config, I am able to obtain these two kind of constants over here. So we've got current and send. Our current is kind of what is happening in your application at that point in time. It's like a massive object which contains contextual information about the machine. And send is how you dispatch actions in order to move between the different states in your machine. So you can see in this app, what it's saying is that if I'm in state info1, then render this in the JSX. When I call complete step, call send, and then move me to the next stage of my application. Is how you progress through the flow. So I'm just going to click demo at the top left. This is just a really simple app kind of showing how this looks. I'm trying to bring up the inspector and failing. Here we go. Cool. So you can see that on the machine Chrome extension on the right, it's plugged into my app. And I'm just going to click here, and you can see that on the DevTools on the right, it's moving through the application. It's interpreting my state machine and seeing that, yeah, we can see exactly how you're planning to move through this application. Cool. So when you're building an application, one of the most common things you want to do is asynchronous behavior. So I want to load some data into my application, or I want from my user to complete an action that's going to take time. So this kind of idea of invoking a promise and doing something if it rejects or resolves is built into XState using the invoke property on the configuration. So you can see here that I've landed myself in a initial state of previous. Sorry, it goes to the loading wizard here, and then we're invoking this get data function. Now, if this get data function succeeds, then it takes the data and it calls a sign. And what that's going to do is it's going to take the data and put it in the context, which you can kind of think of as like a store for your application. But if it fails, it's then going to say, right, don't go to the next stage in your state machine, in your happy path, go to error. Now, what this enables us to do is map the unhappy path. So we can say, right, well, we've loaded the information, it's failed, and now I want to retry. So it's a way of kind of building that predictability even when things go wrong. So I'm just going to show you that in kind of a demo here. You can click on the visualizers. All the slides are available at the end. So if I just bring up that Spectre again. You can see that I'm in this initial state of 1. Now, if I flick this little switch here and I call the complete 1 method, you can see that when it goes into this loading state, it's going to reach an error. Now, when it reaches this error, I can click retry, and this retry action can only be called in this state, which then brings us back, and we kind of get in this infinite loop until I hit this, and we then go and the promise gets resolved, and we reach 3, which is the final state of the application. Cool, so next thing I want to talk about is hierarchical machines. Now, these are also called nested machines, which I always think is an easier way to kind of understand them. And it's a machine within a machine, essentially. So what we're saying is that on the state machine, the parent state will not change until the child states have completed. So it's kind of a way of blocking the user from progressing until they've done certain things. So the example I've got here is like if we had a training info panel, we want to collect some information about the user. They have to enter the number of races they've done. They have to enter how far they've done a week and how many runs they've run a week before we'll let them move on with the journey. And you can see how this is represented in the JSON is very similar to how we've done it originally. So it's kind of states within states. And you can see that when it reaches this final state, that is when it's going to say, yep, okay, you're done. You can move on to the next parent node. So I'll just show you that in a demo. So again, this is another really basic React application. And if you plug it into the machine, you can see that we're in this state 1, and I have to complete steps A and B before it will let me then progress onto these parent states of 2 and 3 and 4. So if I click through, you can see that I've completed step A, but the parent state remains to be state 1. So I have to complete everything before I'm actually able to move on to the next parent state. There we go, you can see you complete the journey there. Now, another thing that you might be thinking is, okay, well, hang on, how about if I've got a user and it's not a linear path, so I want them to go one way dependent on whether something is true or false. So that's also built into XState in something called a guarded transition. Now, a guarded transition means that it's essentially an if statement to say, is this statement true? Based on the context that I have in my application, so the contextual information in the application. And if it's true, then do something, and if not, go somewhere else. So this kind of, in my example of a race kind of wizard here, what we're saying is that if they've done previous races, then ask about it. If not, then skip this stage. So how this looks in kind of a JSON is you've got, when I dispatch the action complete 1, and I can skip 2, then go to 3. But if that's false, then go to 2. So again, that's probably easier to show you in a demo. Cool, so you can see that we start in state 1, and if can skip 2 is true, we'll go to 3. Otherwise, it's going to make us go through this other path in order to complete additional steps. So at the moment, can skip 2 is false, so we'd expect to land in state 2 and then in state 3. Whereas if we try that again, and can skip true to is true, then we'll skip that and we'll go directly to the final state. Cool. So the next thing I want to talk about is parallel machines. So this is kind of a form of nested machine that you can think about as happening in series. So if we have multiple nested machines, we want to wait for them all to reach their final state before we proceed onto the next parent node. So the idea here would be something like if we had a parent node of previous race info, we want to ask about all of those races before we moved on to the next step. So that's represented very similar in kind of the configuration for these for this object. The only difference is that you have this type of parallel at the top to tell the interpreter, okay, you need to wait for all of these states to reach their final stage before we move on. So again, flipping across to a demo, you can see that in the inspector on the Chrome extension, it loads. I'm using an older laptop and it's struggling today. Here we go. So you can see that we're in this parent state of start, and there's a parent state of end. But in order to reach that, we have to complete each of the 3 parallel applications. So you can see if I complete A, we land in state B. If I complete D, you land in state E. And if I complete G, you land in state H. So if I complete all 3 of those machines, we should reach the end state. And you can see it's made that transition. So again, it's just a way of enforcing your user journey to kind of do the necessary steps before you move them forward. Okay, and the last thing I want to talk about is invoking actors. So this is a slightly more complicated concept, but essentially breaking it down, it's very much like you're spawning new machines which can then communicate with each other. So if anyone's used languages, or I think it's more of a framework called Akka, that's sort of how this works. So it's using children of a parent in order to communicate and send messages between them. So this is kind of the best example I could come up with between in the limitations of the analogy that I've got. But say that we've got a parent state called races, and in the context, I've got some objects which represent like an abstraction of a race. We can spawn a service for each of those races, which become their own machine. And then we can talk to the parent and say, okay, send this information to the parent and do something with it. So in this case, we've got this races machine, which when it retrieves the action of selected, will add a race to an array. But you can see that each individual machine has an action of when you click it, it will send a message to the parent. And so that communication kind of goes 2 ways. Another kind of use of this would be, for example, if you created a logging service. So your machine creates a logging service which is listening, and when it retrieves an event, it tells the parent, by the way, this has happened. So yeah, this is something I'd really love to explore a bit more. I think it's an incredibly powerful kind of idea that you can have different parts of a machine talking to other machines and responding to each other. But yeah, so this is really cool. Okay, so this scary diagram that we looked at at the beginning has hopefully been broken down into bite-sized chunks by this talk. I'd really encourage everyone to go away and have a look, because this is a really, I found it a really, really useful tool using both in my kind of professional life and also in personal projects. It's a really good way of visualizing how your application is put together. And we've done a few demos, but I thought we might as well go the whole hog and create this application that I've been talking about, and you can kind of see this full state machine in action. So this is the lace-up state machine. So you can see that initially we are in the info 1 state, and this is essentially just a linear machine which is asking, giving a bunch of information to the user. It's not doing anything but allowing you to progress to the next state. However, when we choose to start the wizard, it's going to say, okay, go away and fetch some data from the server. So when I click continue, you can see there's a loading animation, and we go into this training info state. So what's happened there is that it's gone off, it's got the data, it's found out it's not in an error state, so it's gone to the next route on the journey. And it's placed us in this nested state node. So we have to complete everything on this page before we can progress. So how many races have I previously completed? We'll go for 5. In quarantine, it's not quite so many, but we'll go for 20. And it's around 4 a week. There we go. So when I click continue here, we're going to reach the final state of this nested node, and we're going to progress onto the next step of our journey. Right, so you can see what's happened here is that we've reached a guided transition. So it's worked out that I have previous races, and it's directed me to the next step in our journey instead of skipping it. Because what would be the point of asking information if you know that I possess no information about it? So we're in this now, this parallel state node where we have 3 machines we need to complete in order to progress. So let's say they were all in 2020. One was a marathon, one was a half marathon, and one was a 10K. And let's say that I did it in, we'll be optimistic, 240. Let's say we did that one in 120, and we did that one in 50. Cool, so now because I'm about to reach the final state of all of the child machines, it's going to direct me onto the next node. And there we go. We can see that it's done another promise invocation. It's calculated our race ability as experienced, which is stretching the truth. And what's going to happen now is when I put C races at ability, it's going to take the races that I've gone away and looked for, and it's going to create an actor for each of them. And what we should be able to see in this drop down is that it's created for these 2 events. And if I click each of them, we fulfilled the customer requirement of being able to click on each and get more information about it. Cool. So one of the biggest questions people normally ask when dealing with this technology is, does it replace Redux? Now, the answer is no, not for most people. Where this is really useful is places where you really want to guide your user through something. So the example of a wizard or a payment gateway, something like that. Myself, I use it normally in combination with React Router and Use Reducer. So if I want something in kind of global application state, I'll use Reducer. And then if I want to kind of have a section of my app which is guiding someone through, I'll use a state machine. Similarities, they're both state containers and they essentially both update a store, whereas in kind of XState it's called the context, but it is really a store. But XState, kind of the difference between it and Redux is that the steps are finite, so I can only dispatch actions when I am in a certain state at any point in time. There's a really good kind of Stack Overflow trace that I've linked here where the creator kind of goes into a bit more detail on that. Cool. Okay, so I've nicked these slides from Slides Carnival, so thanks very much to them, and also all kind of praise comes to David for the creation of this technology. It's really cool, and I think it's getting a lot of people talking about improving predictability of front-end applications. That's me. Please, as Luke says, just get in touch if you want to chat about this more, you've got any questions. All the code you've seen today is on GitHub, and these slides are on Google Drive as well. So yeah, please feel free to bug me. Thanks very much.